Well, so let's understand Influxdb schema design and the line protocol. The scenario tells us that we have a temperature sensor located in a greenhouse with an ID and a reading of 25.5 degrees Celsius. As a JSON object, it would look like this. This scenario data is perfect for Influxdb, but Influx doesn't accept JSON. It uses the line protocol. The line protocol reads nicely with the measurement, tags, a space, fields, a space, and then an optional timestamp. If you're not specifying the timestamp, the time of the server will be used. And the timestamps are in Unix time with the default precision of nanoseconds. As you can see, there's a convention for using underscore in the names instead of camel case. So if we compare this to SQL, we can see that the measurement can be thought of as a table, and tags are like indexed fields, where tags can only be strings, and fields are just like normal fields but can have any data type. Now that you have seen an example of an actual data point, I'll zoom out to show how the schema in Influx is. So the Influxdb schema, we have a database, we have our measurement. In our measurement we have our series, and from the previous slide we have a point that is located in the sensor measurement with tags, sensor ID and user location, and the fields of temperature and is Fahrenheit, and finally our timestamp. So a measurement can be seen as like a map where each key maps to a series, and the series identifier, or the key, is consisting of the concatenation of the measurement name, the tag values. As you can see, tag value here, and then the second tag value right after it. So again, database as the biggest unit, measurement, series with points to points, data points. Alrighty, so now that you have seen the different terms of the Influxdb schema and how they are related, I just want to show you how Unix time works and talk a little bit about precision. As you can see here on this site, we have the constant Unix time. So you can see that it's specified in milliseconds. So because this is the seconds and it moves up like one every second. And then by having the Unix time, we can specify our local time. So we know that, or in my time zone, I'm in Sogndal, it's 2 hours past the UTC time. So by storing always in the Unix time, it's easy because we just know we don't have to think about time zone and everything. So as you can see here on this map, we have the standard time zones, and 0, the UTC, is located here in the middle. And then you have my location here in Sogndal at +1, but since it's summertime over here, it's +2. So then let me just show you what I mean about precision. In the Influxdb, when writing a point, we see we have access to a precision parameter, which can be nanoseconds, microseconds, milliseconds, seconds, minutes, or hours. So we have all the way from very coarsely grained to defined, coarsely grained with hours being the minimum precision and the maximum precision of nanoseconds. So before we start designing our schema, a good way is to start writing the queries we want to execute, which brings us to the next section. But before that, please check yourself by taking the quiz.